Okay, hi everyone. As promised, short screencast that covers the very last new thing. This is called the Intermediate Value Theorem, or the IVT, and I promise you it is very straightforward and very simple, and let's get to it. The IVT says the following, and I'll talk about a drawing here in a minute. It says, if f of x is some continuous function, I haven't drawn it in, okay, and I just put 2 points that I know f of x passes through, -1, 4, and 8, -3. The IVT says that if f of x is continuous on the interval in question, which in my drawing here is the interval -1 to 8, okay, then there must be at least one value of x, we'll call it at x equals k, such that the y values must cover the range of y values represented by the function. So in other words, look over here. This is -1. This is y equals 4. This is 8. Here is y equals -3. What the IVT is saying is that if the function is continuous, then there must be at least one x point between -1 and 8, such that the y value equals 2, for example, and that the y value equals -1. Or that the y value equals 3.9, because if f of x is continuous, then, the curve has to connect in some fashion, and as you can see that on this curve here, every y value between -3 and 4, every y value between -3 and 4 must be hit at least once, okay? At least once, by some x value between -1 and 8. So, you can see here, at this y value right here, I'm sure you can take a look at this, that there's a y value right here, maybe you call it y value +2. And there's two different x values between -1 and 8, such that y equals 2. So hence the at least one. Okay. Someone said, and that someone is someone fictitious, so I'm pretending that one of you are saying this. Although I have this feeling, if I were to ask you, who is the person who asks most immediately the kind of what-if questions? Who do you think? Who's your vote for in our class? Who is it? Well, I have my idea. Like, who's the person that immediately asks? Couldn't there be a y value outside of the range of y values, -3 to 4? The answer is yes. Maybe your function looks like this. Sure. Okay. But these y values beyond 4 and lower than -3, they are not in the category of must. Okay. They're in the category of could. Certainly there could be a y value outside of the range of these y values, but the must is the operative word. What absolutely must be the case, if f of x is continuous, is absolutely the case that the y values -3 and 4 occur at least at one x value between -1 and 8. Okay? That's all the IVT says. Now your question is, how could there be a question involved in the IVT? And I just thought of a couple here. Here's one. It says, let f of x be continuous for all real numbers, and let f of 3 be positive and f of 4 be negative. What graphical feature of f of x must exist between x equals 3 and x equals 4? Well, go ahead and see if you can answer this question yourself, and then replay me for the answer. Well, the answer here is this. If you know that there's some function that's continuous, and that f of 3, the function is positive, and at f of 4, the function is negative, if f is continuous, well then that means f of x must have a root somewhere between 3 and 4, because according to the IVT, over some interval over which the function is continuous, so over the interval of 3 to 4, every y value must be accounted for at least once by an x value between 3 and 4. So between 3 and 4, f of x must have a root, according to the IVT. Here's another variation of the question I could think of. It says, for some function f of x, we are told that f and its derivative are continuous functions for all real numbers. Okay, that's interesting. So not only is f continuous, the second function, f prime, is also continuous. Okay. If f prime of -7 equals 0.7, and f prime of negative 6 equals negative 1.2, okay, why must a relative, maximum of f of x exist for some x value between x equals negative 7 and x equals negative 6? Well, once again, let's just kind of talk about here the function that is continuous here that I'm going to talk about is f prime. We're told f prime is continuous, and we're told that at negative 7, f prime is 0.7. This is the graph of f prime now. And at negative 6, f prime is negative 1.2, right? And we're told f prime is a continuous function. Well, according to the IVT, if the function in question is continuous over the interval from negative 7 to negative 6, that means every y value must be accounted for at least once, and every y value between negative 1.2 and 0.7. Therefore, f prime must equal 0 at some point between negative 7 and negative 6. And if f prime equals 0 at this point, you will see here that from negative 7 to this point, f prime is positive. And then from this point to negative 6, f prime is negative. So we know that f prime has to have a root there by the IVT, but then by the first derivative test for extrema, f must have then a relative, max somewhere between x equals negative 7 and x equals negative 6, and because of what was the justification? Because of the first derivative test for extrema. Okay, told you, very straightforward, IVT. And I thought of a third one. I said, how can I think of one that involves, like, I don't know, something else? But okay, consider the table of values below. F and f prime are continuous for all real numbers. So I gave you values of x, f, and f prime. Okay. Why must f of x equal 5 for some x value between negative 3 and 2? Okay. Well, how about I have you do that? Okay. Why don't you answer that question? Okay, here I go. Well, by the IVT, because f of x is a continuous function, over the interval of x from negative 3 to 2, okay, there must be at least one x value between negative 3 and 2 such that a y value of 5, and notice that 5 is between the range of y values 2 and 7, right? There must be at least one x value such that f of that x value would equal 5, because 5 is between 2 and 7, and between negative 3 and 2. So here's what I'm looking at here, right? Even you have to look only at the endpoints. Between negative 3 and 2, so here's negative 3, here's 2, negative 3, it's 7 here for f, and the 2 is 2. It's kind of cute, okay? So, but because f is a continuous function, according to the IVT, there must be at least one x value where the y coordinate is 5, because 5 is right between the range of y values 2 and 7. All right, and then part B, between what two integers must a relative extrema of f of x occur? Well, again, because f prime is a continuous function, I'm looking right here. Between negative 1 and 0, because f prime of negative 1 is negative, f prime of 0 is positive, somewhere between negative 1 and 0, f prime must equal 0 according to the IVT. And and at that point where f prime equals 0, there will be a relative minimum. Okay, so that is the IVT. There actually are not a whole lot of questions in your book about the IVT, and I told you that it's pretty straightforward. And do you agree? Good. Have a great day, and I will see you on Thursday. Goodbye.